Hello, everybody. It's about time to start, but in the remaining 30 seconds before the official start time, I have one sticker. Now, so the important thing about this sticker is that it is one of three that are at this conference. I've asked everybody, and there are only three. So we printed up a bunch of these for the last summit in Berlin, and apparently we thought that would last forever, and we were wrong. They're all gone except for these three. One of them has a dog ear, so let's call it two are left. So I'm gonna give one sticker away at the end of this talk if somebody asks a pertinent, keyword pertinent, question about Zuul that I haven't heard before. So start thinking. My name is James Blair. I started the Zuul project. I'm the current project lead. And I have a business called Acme Gating, which supports Zuul, helps enterprises run it, custom development, consulting, that sort of thing. And I also volunteer my time as part of the OpenDev infrastructure team. So I help run the Zuul that OpenStack uses for its development, the Garrett, those systems. And so what I'm gonna talk about today is something that we use the OpenDev Zuul for. Basically, it's a really specific use case for how we use Zuul, and it's kind of an introduction to all of the power that you can get from Zuul. So what we do is whenever we want to make a change to, say, the production Garrett system, the production Zuul system, there's a Grafana, there's mailing list servers, there's all of the things you need to run an open source project. Whenever we want to make a change to any of those, it's all gitops, right? So we make a change to the Git repository, we push it up for code review, and as part of that, Zuul deploys an entire ephemeral system. So if we're talking about making a change to the Garrett server, it's going to get a VM, spin up the Garrett server using the new code with the change that's been proposed, and run some tests on it, possibly let some humans evaluate it, kind of depends on what we're going for. And then when we're done, it destroys that like it was never there. And so this gives us a very high degree of confidence about any of the changes that we want to make to our production environment. So I'm going to talk a little bit about how Zuul does that. We call this process speculative ephemeral production because we like using those words in various combinations. Speculative meaning that we're talking about like what happens if we make this change. So we're not testing what happened after we made this change. It's more like, well, what if we did this? What it would look like? And then ephemeral, of course, referring to the fact that we spin up the new copy and then delete it when we're done testing it. So Zuul is, as I've alluded to, the project gating system that was originally developed for OpenStack. Part of the reason why we developed it in the first place for OpenStack is OpenStack has all of these different projects like Nova and Glance and Keystone and yada, yada, yada. And they all kind of get developed independently. But at the end of the day, we want them all to work together and ship something called OpenStack. And so Zuul is really designed for that use case, for having lots of projects, lots of Git repositories, and then incorporating them in various ways to produce some whole. And I think I've talked about the other stuff here. So why is Zuul useful for this use case, this speculative ephemeral production? I said that right twice in a row now. So the first is Ansible jobs. So Zuul's native job language is Ansible. And when we were looking to create Zuul, we're like, oh, well, should we write our own YAML language to talk about how to run things on remote servers? And we're like, no, you know what? There's actually a thing out there that does that already. It's called Ansible. So, so yeah, just like how many people use Ansible to say, run this particular command or whatever on some remote machine or 100 remote machines or whatever, the same thing is true in testing. You want to get a test machine, you want to run a command on it. Maybe your job is complicated and you need a Nova and a Glance and you need to run the commands on both of those and they're different machines. You can describe how to do that in Ansible. Zuul is Git driven, as I've discussed. So our production infrastructure is gitops. Zuul is triggered on changes to Git repository. Its purpose is to mediate the merging of changes to Git repositories, so only merge them when they successfully pass tests. So that's a natural fit. Zuul allows centralized or decentralized control. So you know what, actually, I'm gonna skip ahead of here. So I've got what I call the Goldilocks control model, right? Where it's like maybe you want everything to be centrally defined. You've got like a CI team and they do everything. You can do that with Zuul. You can say these are the job definitions, these are the repos where those are. Or maybe you want to give individual teams more control. Say that they're gonna run these jobs on this Git repository. Maybe you need something in the middle. Maybe all of your projects need to run sort of a basic set of jobs. You've got some standards around code coverage and unit tests and things like that, and you want everybody to do that, and then have projects sort of add on what they need as well. So Zuul allows really anything, anywhere on the spectrum. Cross-repo dependencies. This is really important for this particular use case. We're talking about not only our deployment code, but sometimes we want to make changes to the applications that we're deploying. So with Zuul, you can set it up so that, say, you wanted to not only just change something about how you deploy the Gerrit server, let's say you wanted to write a change to add new functionality to Gerrit and then deploy it in our environment and see what that looks like. This is a real thing. Somebody in the audience has actually written this change where it added, so we've got Gitty, right, in OpenDev, and we needed Gerrit to link to Gitty. And so we actually had to make a change to Gerrit to implement that and then test how that works in our deployment. So thanks, Clark, for doing that. Then finally, speculative execution, right? This is really what it comes down to. You can make changes to libraries, you make changes to front ends, you can make changes to your infrastructure deployment code, and like I said, get an entire ephemeral environment that tests all of those together. So Zuul uses a number of potential environments for running its tests, right? So you can tell Zuul that you need a virtual machine to run a test on. You could tell Zuul that you need to run tests on Kubernetes, on OpenShift, in pods, whatever. Zuul is really flexible about how you, what actual environment it's running its tests on. So whatever kind of ephemeral infrastructure you need to do this particular kind of problem, Zuul should be able to handle it. In the case of OpenDev, since OpenDev runs on OpenStack clouds, our natural bias is sort of to run things on OpenStack virtual machines. So when I get into the example in a minute, this is all going to be on basically on virtual machine, OpenStack virtual machines that we spin up and deploy this on. So because I'm kind of a sort of a hands-on person, I'm going to walk you through a very specific example of how we do this, our Grafana deployment. So I chose this because it's probably pretty relatable. Maybe not everybody in the room runs a Gerrit, but probably more people run a Grafana. So it's basically there's a host out there. You can go to it right now, grafana.opendev.org, and that's where we have a lot of metrics for the Zuul system and the other systems that we manage. And it is completely part of the system that I'm talking about. You could check out the repository with all of our deployment code. You can make a change, push it up for review, that sort of thing. Try to make it a good change, like maybe not delete the Grafana server. That's not helpful. So what do we do what are we going to look at? So there's the base playbook. What we at the beginning of this test job, what we do is we run the base playbook that we run on every system, right? Like this is the one that adds our SSH keys and adds the firewall rules and turns on or off mail as appropriate, all of those things you have to do on every server. Then there's the Grafana playbook, which actually deploys Grafana itself. The inventory file is interesting here, right? Because in production, we have one inventory file. In testing, we have a different inventory file. So how do we manage that is kind of an interesting question that I'll talk about. We have a bastion host that we call Bridge. Actually, I think now we call it Bridge 99 in testing, and we call it Bridge 02 in production. Anyway, there's a bastion host, and that's where we run our production deployment playbooks. But in our ephemeral test environment, not only do we need an ephemeral Grafana server, we need an ephemeral bastion server too. So this job is actually not only going to spin up the server that we're testing, it's also going to spin up the bastion server. So we're not testing, like, does this thing work in this really contrived test scenario? It's actually, no, if we spun up a brand new Grafana server and a brand new bastion server and then run the production playbook just like we run it on the real bastion server, is that going to work? So that's involved in this as well. And then, of course, there's Ansible configuration files. So in Zuul, you define jobs via YAML because, I mean, what else would you do? So there's a job that we have called system config run Grafana, which is a weird mouthful, but that's like follows a naming system that means things to some of us. This next thing on it, this is slightly abbreviated, by the way, just so there's some more boring stuff, but this is the interesting bits. The next thing on there is requires line, which says, basically, in short, it says, if for some reason you decided you needed to build a new Grafana container image, like a new Grafana Docker image, say somebody was also updating the Docker file for Grafana, then make sure you do that first, because this job requires the output of that other one. If you're not actually making a change to that, then that's fine. It'll just run this with the current Grafana container image. So again, this is getting back to that sort of speculative execution, cross-repo dependency thing. It doesn't really matter where the Grafana container image is defined. If it's in another repo, that's fine. We can use the one that's built in that other repo. This rabbit hole goes really deep in terms of how many unmerged changes to the entire system you can incorporate into it. The required projects means check out these Git repositories, right? So the system config project and the project config I'm gonna be upfront, we're bad at naming. Anyway, these are important Git repos that have our production configuration, and we're gonna need them on disk to actually run some of this. So the next thing is the node set. This says, Zuul, I'm gonna need 2 servers. One of them we're gonna call Bridge 99, and the other one we're gonna call Grafana 01. So Bridge 99 is a tiny cheat because it turns out there are a few things that you have to do on an ephemeral bastion host that you can't actually do on a production bastion host, and vice versa. Bridge 99 is basically, as close to our production bastion host as we can possibly get. Also, it gives us a warm fuzzy that we're never going to accidentally shell into the real one. Anyway, so create the new bastion host, create the new Grafana server. Our bastion host actually isn't running Bionic anymore, is it? No, it's been upgraded to Focal, so I need to update the slide. Anyway, it says what operating systems to ask OpenStack for, what flavors. Then there's some job variables. So our playbooks look for these variables, and basically we have playbooks that run playbooks, and so this is saying, hey, big main playbook, run these other small playbooks, and these other small playbooks are like the Let's Encrypt playbook and the Grafana service deployment playbook. So these are the things that actually deploy the service, and those are our actual production playbooks that we're running in our test environment. So the test run, what it does is it starts off by running a playbook that we call the base pre-run playbook. That sets up our test hosts. It sets up any mirrors that we're using in our test environment, that sort of thing. And then we run the base playbook. And again, this is the thing where we eventually the purpose of this is to like install our SSH keys and all that stuff, right? But the first thing that it does as part of that is it takes the Zuul inventory and creates an Ansible inventory file. So Zuul has its own inventory for running Ansible, but because of the way we're testing this, we're testing this by having Zuul's copy of Ansible run a second copy of Ansible, which is, again, exactly how we do it in production. So this is the point where, say you use Terraform or something like that, and you want to do this with Terraform. You would have Zuul's Ansible playbook run Terraform, right? But since we use Ansible for our production, we're going to have our Zuul Ansible run our sort of nested Ansible. So as part of that, we take the inventory file that Zuul created, and we create a new inventory file to hand it to our nested copy of Ansible. Then we run the actual base playbook, the thing with the SSH keys and all that. Then we run the playbooks that we specified previously, like the Let's Encrypt and the Service Grafana playbooks. We call those that's the run playbook that does that. And then we have a test playbook. So the run playbook is do the thing you do in production. The test playbook is another playbook we run after the end of that, and that does things like run the test info program. I don't know if everybody's familiar with that. If not, it's basically a Python program that's sort of like unit tests for production systems. So it does, you write tests that are things like, is my service up? If I talk to it, do I get the expected response and things like that? So we run that playbook after this, and that's how we use to decide in an automated way whether the change is good or bad, and we vote positive or negative on it. So yeah, sorry, like I said, the test playbook is check supports are listening, HTTP queries, any other things that we want to do. Also, we might want to capture the logs from our ephemeral test system, because our logs aren't going to go to the normal place where production logs go. We need to pull them off of the test system. So that's something that we don't do in our normal production playbooks, but we do need to do in this environment. So yeah, sort of anything you know, after you've simulated your production environment, anything else that you want to do after that, we put in our test playbook. So when this job runs, if you go to Zuul and look at the build result, it's going to look something like this. So here's a random change that I selected. I actually don't even know what it does, but you can see that it finished successfully, and some other sort of metadata about the change. Down here at the bottom, there's a bunch of tabs, task summary, and whatnot, and I'll walk through that real quick. So the task summary looks like this. It's basically, when you run Ansible, you know, at the end, it's like, hey, here's the host that I ran a certain number of tasks on. This is the web version, the Zuul web version of that. So we had a Bridge 99 host and a Grafana 01 host, and we ran a bunch of stuff on them, and everything was good. Over on the console tab, this is a kind of interactive recording of what Zuul's Ansible did. So you can see that it ran the playbooks that I was talking about, the run base pre, the run base playbook, and then inside of those playbooks you can see a summary of each of the tasks. And if you click on it, you can drill down into all the parameters for the tasks and everything. So it's pretty handy for debugging. If you pulled any logs off of the system, this is where they'll be. So you can see that for the Grafana server, we pull off the like the IP tables rules, the syslog, the mail server logs for probably no particular reason, because I don't think this sends mail, but they're there anyway. And then the Docker logs as well. And the way OpenDev runs Grafana is via Docker Compose. So this is going to be the Docker Compose logs. And then under artifacts, if the job built any artifacts, like a tarball or a container image or something like that, it would be here. For these jobs, well, we actually do something, a couple of interesting things. There's the ARA report, because we're running a nested version of Ansible inside of this. We actually have the nested version use ARA to generate an output of all of its tasks. And then we take screenshots. So we do like a Selenium thing so that you can, if you make a change to the Grafana server, you can actually get screenshots of Grafana running your change. And that's all automated. So here's the ARA output from the inner playbook. So at this point, there's nothing like this is running something that's just like we would run in production, and this is the same output that we would get from our production servers. Likewise, we have one thing. I don't know if you've noticed. Everything else has a dark theme up to this point, but our test infra system does not. So we'll be blinded by the white background test results there. But you can see that we've got unit tests for all of these things, and you can drill down and see if they passed or failed there. And then here is one of the screenshots that the test automatically took. So it spun up a Grafana server and went to the main page and took a screenshot. So there it is. And then as sort of a bonus, not only can you run this ephemeral test environment that I'm talking about, but using the same playbooks and everything, you can run the actual production code. So we have a job on the system as well called infraprod service Grafana, and that runs these same playbooks, but in the production context on the production server. So if we made a change to Grafana and pushed that up for review, and everything looked good, and we merged that change, then this job is going to run those playbooks against the production system. So there's kind of a lot of magic behind this that I've glossed over. One thing in particular I think is interesting about all of this is basically the problem in general of how do you speculatively test container images. And we've solved it. Actually, we've solved it a couple ways in OpenDev, but we're using only one of those right now. And so really quickly, I want to kind of go over why this is challenging and what choices we've made so far and what choices might be available in the future. So there's a few problems here. One is building speculative container images. So even the act of doing a Docker build on a container image in Zuul's idea of a speculative environment, that can be complicated because your container image, say Grafana, might depend on another container image in the same system, like a lower level layer, and that container image itself might have its own pending changes. So you might want to make a change to, say, a base image that you use for all of your services, and then you might want to make a change to the Grafana image that is built on top of that. Well, if you're doing that, you need to, you can't, it's really awkward to change the from line in your Grafana container image to point to some unmerged random container image that's out there. You could do it, but it's a bad idea. You're going to forget to do it. You're going to get it wrong. You're going to forget to remove it when you're done testing, whatever, right? You want to leave the from line the way it is. You want the from line at the top of the Grafana image to say from my base container image, and still have the system pick up any dependent changes that you're working on there. So, so there's the problem of how do you build chains of speculative container images and get all of those changes in there. Then once you've got those images built, how do you run them if you're using Docker, and how do you run them if you're using Kubernetes? And those turn out to be very different answers. So when you're doing speculative container execution, it turns out the answer is different if you're using Docker Hub or if you're using something else. And that's because the folks at Docker Inc., they made one way of configuring mirrors for images if you're using Docker Hub, and the way that they made for if you're using images anywhere else is they said don't do that. So if you're using Docker and your images are published on Docker Hub, then what you can do is configure Docker to use a mirror. And what we do in OpenDev in this case is we configure something called a build set registry, which is, you guessed it, an ephemeral registry that only exists for the lifetime of this test. And we put the images that the test needs in there, and then the job uses them sort of transparently. Now, if you're not using Docker Hub, then probably what you should do is not use the Docker command line, instead use Podman or its friends. If you're doing that, you can configure build set registry mirrors no matter where your images are hosted. And then there's a third option, which is you can kind of cheat a little bit. Instead of doing this mirror thing, you could pre-prepare your, which might just be preparing, your container environment by sort of side-loading the images into it before you start running your test jobs. That works fine. The tricky bit there is you're letting a little bit of extra work that you're doing for test leak into this process, which, and if if we went back to the other slide, you'd see that all of the test-specific stuff we tried to keep after the production playbooks. This you'd have to do before the production playbooks. So it's introducing a delta between test and production, which you have to be really careful about accounting for. So for speculative image building, basically it's the same thing. I think these slides are in fact the same, depending with different titles. So again, if you're using Docker build and your images are on Docker Hub, then that's fine. Otherwise, you want to use Podman build or Builda or any of the other things that use a Podman-like build system. And then once again, you could sideload the images into the local container environment. Now, if you're using Kubernetes, the Docker runtime in Kubernetes is deprecated now, so there was a way to do that, but we're not maintaining it anymore in OpenDev, and I'm not going to talk about it because it's not really relevant now. But containerd is there, so you should be able to configure containerd to use the build set registry underneath Kubernetes. So this is kind of some minor surgery you're doing on the Kubernetes environment before you use it. But for the testing that we're doing in OpenDev that relates to Kubernetes, that works for us, so that's great. Another way is, again, the sort of, I'm going to keep calling it side loading because that's what it feels like. So say you're using kind or something like that. You can tell kind, like, hey, stage these images inside of your environment. So that works. And then the sort of nuclear option is the mutating admission controller, which you can stick inside of your Kubernetes cluster. And that's a thing that isn't really the focus of this talk, but I am giving a talk about it tomorrow on the Lightning Talk stage in the Open Infra Marketplace. It's basically all of this, but really focused on the Kubernetes specific use case. So it does a lot of the work for you transparently for the building and the deployment of the images. So come and check that out if you're interested. But in general, that is an option as well. You can use a mutating admission controller to switch around which actual images the Kubernetes system uses. So if you'd like to learn more about Zuul, ZuulCA.org is our project's website. OpenDev is the thing that I've been talking about that hosts all of this stuff. Cogate is up and running. It's in sort of a beta test mode, so if you want to look at it and ask me about it, I'd be happy to hear about that. And that's my contact information. Feel free to contact me about anything. And I think we have 20 seconds for any questions. Okay, I'm just going to keep that sticker then. So, all right, thanks. And there's, I've got like some pamphlets about Zuul and stuff up here if you'd like them as well. So thank you very much.